Hello everyone. Now we have to discuss problems on two-port networks. Coming to the first problem, the lattice circuit has the following impedances, right? This is the lattice network. We are having the impedance, series arm impedance is what? 3 plus J4, like that. Diagonal arm impedance is nothing but 3 minus J4. Then we have to calculate the impedance parameters. Those are nothing but Z11, Z12, Z21, Z22. So in this, this is ZA, right? Like that. This is ZB. So for this, first I would like to explain the generalized analysis to get Z parameters if the lattice network is given. Okay. Modified lattice network. So this network should be modified. For example, this is A, this is B, this is C, this is D, right? Okay, next. This is plus minus, this is V1. Okay, the current through this port is nothing but I1, like that. See, from this is V1, right? This is V2. So let us say this is A, this is B, this is C, this is D. That's it. So in between this C and D we are having what? V2, right? This is V2, this is plus, this is minus, right? Next we are having what? Z1. Let us say this is Z1, Z2, Z2. See, between A and C we are having what? Z1, for example, Z1, because the circuit is symmetrical, right? Series arm impedances as well as diagonal arm impedances are same. So this between A and C we are having Z1, like that. Between D and B, between B and D we are having Z1, like that. So this is the modified lattice network from the given network. Now the current for this input port is nothing but I1, therefore the current through this branch is nothing but, let us say, I dash, through this is nothing but I double dash. That's it. Current division takes place because these two are connected in parallel. The source current is nothing but I1, this is I1 dash and I1 double dash. So by KCL, I1 dash plus I double dash should be equals to I1. So first we have to get the equivalent impedance from source terminals. First step, Z equivalent from input terminals. That is, Z equivalent is what? This branch and this branch is connected in parallel. So this is Z1 plus Z2. In this branch, Z1 plus Z2. So what we are having? Z1 plus Z2 parallel with Z1 plus Z2. From this we are having Z1 plus Z2 by 2. So this is the Z equivalent, which is nothing but what? Z equivalent, which is equals to Z11, which is equals to V1 by I1, which is equals to Z1 plus Z2 by 2. Since V1 which is equals to Z equivalent into I1, right? Because by looking between these two terminals only we are calculating Z equivalent, therefore V1 is equals to Z equivalent into I1, that's it. Next, now V2 which is equals to, see the diagram, V2 is equals to what? The total voltage across is what? V1. V2 is what? Which is present between C and D. Therefore, V2 is equals to EC minus VD. That's it. Therefore, where VC which is equals to what? Total voltage is what? V1. V1 minus drop is what? The current through that branch is nothing but I dash into Z1. See. The total voltage across this branch is nothing but V1. The current through the branch C is nothing but I dash into Z1. Like that, through this Z2, I double dash into Z2. That is, and VD which is equal to total voltage is V1 minus I double dash into Z2. That's it. Then, from this V2 is equals to, therefore, V2 which is equals to VC minus VD, that is V1 minus I dash Z1 minus V1 plus I double dash Z2. So V1 gets cancelled, therefore V2 which is equals to I dash to Z2 minus I dash into Z1, right? This is V2. This is V2. Next, what we have to calculate? Individual currents I dash and I double dash. I dash is what? Total current, apply current principle, into opposite branch resistance is what? Z1 plus Z2 by total resistance, that is what? 2 into Z1 plus Z2. From this we will get, which is equals to what? I1 by 2. Similarly, I double dash is also, because same value of impedance is present in parallel branch. Therefore, I dash is I1 by 2, I double dash is nothing but I1 by 2. That's it. Source current by 2. Therefore, V2 which is equals to I double dash is what? I1 by 2 Z2 minus this is what? I1 by 2 Z1. V2 which is equals to what? We are having, sorry, Z2, upper part is what? Z2, right? This is Z2, Z1. Z1, right? From this, I1 by 2 is gets common. This is Z2 minus Z1. From this, we have to get V2 by I1, right? V2 by I1 is equals to Z2 minus Z1 by 2, which is equals to what? V2 by I1 is nothing but what? Z21. That's it. So finally, what we have? Z equivalent is what? V1 by I1 is nothing but Z1 plus Z2 by 2. Like that, V2 by I1, that is Z21 is nothing but Z2 minus Z1 by 2. So, by by inspection you can say that the circuit is symmetrical. Why? Since series of impedances are equal and diagonal are impedances are equal. Therefore, finally, therefore, that is symmetrical Z11 which is equals to Z22 which is equals to what? Z1 plus Z2 by 2. Like that, Z12 which is equals to Z21. These are nothing but diagonal. That is Z2 minus Z1 by 2. That's it. This is the conclusion from the analysis. Therefore, from given problem, Z1 is what? Given as 3 plus J4 ohms. Z2 is what? 3 minus J4 ohms. Therefore, Z11 we have to calculate, right? Z11 which is equals to Z22 which is equals to Z1 plus Z2 by 2, that is 3 plus J4 plus 3 minus J4 by 2. From this we have what? 3 ohms. Like that, Z12 which is equals to Z21 which is equals to 3 plus J4, sorry, 3 minus J4 because Z2 minus Z1, right? 3 minus J4 minus 3 plus J4 by 3, sorry, by 2. So 3 gets cancelled. From this we have what? Minus J4 ohms, right? Finally, what we have? We have to calculate the impedance matrix. This is what? 3, this is minus J4, this is minus J4, this is 3. That's it. This is the answer. Option would be 3 minus J4 minus 3. Option would be B. This is problem 1. Next we have to discuss the Y parameters of the network shown in below. So from this we can use apply source transformation, then the circuit becomes what? That's it. And we have what? Then this is what? Like this. This is like this. This is plus minus. This is P2. This is V1. That's it. From this, the current through this port is nothing but I1. Through this port, I2, right? And the given data, this is 25 ohms. This is 100. We all know that this is current source, this is resistive branch which are connected in parallel. So this is what? 200 I1. This 200 I1 is nothing but voltage Yeah, 200 I1 is nothing but voltage value. Okay, then from this is what I1 I2, that's it. From loop 1, from loop 2 we have to obtain KVL equations. From loop 1 we are having what, V1 which is equals to 25 I1 plus 100 into I1 plus I2. This is also voltage value, that is minus 200 I1, that's it. So from this V1 which is equals to what, 225 plus 100 minus 200 minus 75 I1 plus 100 I2, like that. From loop 2 V2 which is equals to 100 I1 plus I2 minus 200 I1. So from this V2 which is equals to what, minus 100 I1 plus 100 I2, that's it. This is from loop 1, this is from loop 2. Now we all know that this equation and this equation all looks like what, they are matching with the governing equations of Z parameter representation. Therefore Z11 which is nothing but minus 75, okay, 75 ohms. Z12 is what, 100 minus 100 100, right, 100 minus 100 100 ohms, that's it. We all know that we have to get what, we have to get Y parameters. So to get Y11 which is equals to what, Z2 delta Z by Z22, like that. Y12 which is nothing but what, minus Z12 by delta Z, like that. Y21 which is equals to what, minus Z21 by delta Z. Y22 which is nothing but what, Z11 by delta Z. Sorry, this is Y11 is nothing but Z22 by delta Z, that's it. From this we can have Y11 which is equals to 0.04 Y12 minus 0.04 Y21, we are having 0.04 Y22, we are having minus 0.03. So these are the Y parameter representations. So next problem is, consider the two-port network as shown below. The hybrid parameter H12, we have to calculate H12 only. So from this, so to get H12, you all know that to get H12 which is equals to V1 by V2, that is I1 which is equals to 0. Only he wants what, H12 only. Therefore H12 is what, input supply voltage by output supply voltage when input port is open circuited, right? Then the circuit becomes what, when at this condition the circuit becomes, because we don't have this branch, only we are having that's this is alpha I1, this is R3, this is R2, plus minus across we have V2, that's it, right? The current through this branch is only I2 only, because I1 is 0, therefore this is what V1, right? When it is open circuited, this is V1. So we all know that this is I2. What about this? This is also I2, right? This is alpha I1. Here I1 is equals to 0. This is the modified circuit from this. So here also I can apply source transformation. Okay, then the circuit becomes right. This is what we all know, that this is V1, this is what R2, this is simply I2, because I1 is 0, therefore the only current through this branch is nothing but I2 only. This is V2, this is what R3, this is given as alpha I1, but after source transformation we are having R3 alpha I1, that's it, clear? Then the current through this branch is nothing but only I2, clear? Therefore from this, first we have to write what is this V1, V1 which is equals to I2 R2, clear? Let us say this is 1. Next V2 is what? This V1 minus, this is nothing but voltage, right? In this branch this is nothing but voltage, R3 alpha I1, R3 alpha I1, because R3 and alpha I1 are connected in parallel. Therefore this is second V2 which is equals to I2 R2 minus R3 alpha I1. We know that alpha I1 is nothing but minus I2, right? Alpha I1 is nothing but minus I2. From this I2 is nothing but minus alpha I1. Okay, therefore V2 is nothing but minus alpha I1 R2 alpha I1 R3. Therefore V2 which is nothing but minus alpha I1 R2 plus R3. Okay, yeah, V2 is like this. We want only H12, right? Only H12 which is equals to what? V1 by V2 when I1 which is equals to 0. Therefore H12 V1 is what? V1, sorry, V1 already we know that. V1 is what? I2 R2 by minus alpha I1 R2 plus R3 H12 which is equals to I2 R2 minus alpha I1 is nothing but I2 only, therefore R2 plus R3. So from this I2 gets cancelled, therefore H12 which is equals to R2 by R2 plus R3, right? So this is the parameter for 1 to H12 R2 by R1 plus R2 plus R3. Next question, the H parameters for a two-port network are defined by like this. For the two-port network shown in figure, the value of H12, here also we can calculate the value of H12. So here I am providing the solution of Z parameter representation. So with that Z parameter representation, we can get the value of hybrid parameter representation, that is H12. Okay. So what is the procedure to get Z parameter representation? Obviously we have to open circuit input port as well as output port. From that we can get the values of Z11, Z12, Z21, Z22. Right? Next, first solution. Open circuit output port, that is I2 which is equals to 0. This is first step. So when it is open circuited, obviously the circuit becomes what? We have 4 ohm branch, we have 2 ohm branch, and again 2 ohm branch, then 4 ohm branch. That's it. You don't have any okay. This is what? 4 ohms, this is 2 ohm branch, this is 2 ohm branch, this is 4 ohm branch. That's it. When the output port is open circuited, this part is 0, right? Because there is no current through this branch. There is no current through this branch. Okay. Then only the supply voltage is nothing but V1 only. Due to that we have I1. That's it. So therefore the current through this branch is I dash, through this I double dash. That's it. Now, or you can say simply you have to consider only one current. Okay. Only this is I1, this is I. It's better. So from loop 1, from loop 1, what is the equation? See, we have given that this is E1, right? This is not V1. Yeah, E1 which is equals to 4I1 plus 2I1 minus I, then E1 which is equals to 6I1 minus 2I. That's it. This is 1. Next, from loop 2. Next, 2 into, because I minus I1 plus only we have what? 6I which is equals to 0. From this 8I which is equals to 2I1. Therefore from this I1 which is equals to 4I, right? I1 which is equals to 4I, right? When now when I2 is equals to 0, we all know that when I2 which is equals to 0, what we are having Z11, right? That is E1 by V1 and Z21, that is E2 by V1. The first Z11 which is equals to what? E1 by V1, which is equals to E1 is what? From this equation 1, 6I1 minus 2I. 6I1 minus 2I. V1 is what? V1 is what? Sorry, I1, right? I1 is what? 4I. This is I1. This is nothing but 4I. We all know that I1 is nothing but what? 4I. So this is 24I minus 2I by 4I. Therefore Z11, which is equals to 11 by 2 ohms. So from this we are having Z11 as 11 by 2 ohms. Clear. Now it's time for Z12. Z12, which is equals to what? E1 by I2, which is equals to E1 is what? 6I1 minus 2I by I2, right? Sorry, E2, this is E21. E21. E2 is what? 4I. See, what is I2 is equals to 0? This is E2, right? Then write this is E2. The current through this branch is nothing but I. So 4 into I is nothing but E2. Now we can write that this is this is 4I. What about I1? I1 is nothing but 4I only, right? Which is equals to 1 ohm. So Z21 is nothing but 1 ohm. So when I2 is open, we are having Z11, Z21. That's it. We are having those values. Now output port 1 is open. That is I1 should be equals to 0. At this condition, the circuit becomes, right? This is one branch, again one branch. That's it. Here, this is 2 ohm branch. This is what? 2 ohm branch. This is 4 ohm branch. Sorry, here also we are having one branch. 2 ohm branch. Then the current through this branch, when I1 is 0, only we are having I2, only the supply voltage is nothing but only V2 minus. So this is I2. Now this is I. Then what about this? This is E1, right? Which is equals to what? 2 into I. Now it's clear, right? This is E2. That's it. Now from loop 1, what we are having? We are having E2, which is equals to 2I2 plus 4I2 minus I. From this E2, which is equals to, from this E2 is equals to minus 6I2 plus minus 6I2, yeah, 2I2 plus 4I2, 6I2 plus 6I2 minus 4I, right? Minus 4I. This is 1. Like that, from loop 2, what we are having? See, 4I plus 4 into I minus I1, which is equals to 0. From this 8I, which is equals to 4I2. Therefore from this I2, which is equals to 2I. That's it. Same analysis from case 1 when I2 is equals to 0. Therefore when I1 equals to 0, what we are having? We are having Z12 which is equals to what? V1 by I2, like that Z22 which is equals to what? V2 by I2. That's it. Now we have to get the value of Z12 which is equals to what? E1 by I2. E1 by I2. What is E1? We all know that E1 is what? Which is equals to 2I by 2I. Obviously I2 is equals to 2I. So 1 ohm. Z12 which is nothing but 1 ohm. Clear. Now we have to get the value of Z21 which is equals to what? E2 by I1. What about E2? See, E2 is what? 6I2 minus 4I. 6I2 minus 4I by I1 is what? 2I. But we all know that I2 is nothing but 2I. Therefore 12I minus 4I by 2I. So from this Z21 is nothing but what? 4 ohms. So Z21 is nothing but 4. So we are having Z11, Z12, Z21 and Z22. This is Z22, sorry. Yeah. Z12 completed, next Z22, right? E2 by I2. E2 by I2. This is 2. That's it. Now we are going to get the values of, first we have to get H12, right? Therefore H12 is what? We all know that from Z parameter representation H12 is not Z12 by Z22, right? Therefore H12 which is equal to Z12 is nothing but 1, Z22 is nothing but 4. That is H12 which is equals to 0.25, right? This is the answer. Like this you can calculate H11, H21, H22. That's it.